Okay, thanks. Thanks, Aurélien. Okay. So next, we will have Sébastien Buisson talking with Lustre Kerberos update.
Sébastien Buisson has been working with Lustre for over 15 years, initially solution and development activities for Bull, but in recent years focusing on Lustre development at DDN. He's a recognized expert in the area of Lustre security within the Lustre community and has presented various topics in this area at Lustre conferences over the years. He's currently working in Web Cloud Engineering Division at DDN and is based in Grenoble, France.
Hi everyone. So with this presentation, I want to provide you with an update on the latest news about the Lustre Kerberos feature. So obviously there will be some overlap with the previous presentation from Aurélien, but I guess this is what the whole learning process is about, a repetition, right? So here's the outline for today. So first, why would we need strong authentication for Lustre? Then what are our options if we want to or have to implement strong authentication with Lustre? And then a focus on Kerberos, a quick tutorial on how it works, how to implement the feature, and I will detail the most recent improvements we've made in this area. Okay, so let's get started. Why would we need strong authentication for Lustre? Lustre is a high-performance parallel file system, right? So we could consider that only performance matters. That's not exactly true, and some customers have to comply with regulations. For instance, if you have data sets that contain medical records, for instance, then you have to comply with the GDPR regulation in Europe. So you have some legal requirements for security in general and authentication in particular. Also, you can operate Lustre in such environments that would, incline you to implement strong authentication. For instance, if you are using your Lustre as a home directory for end users, or if you are running in a multi-tenancy environment, you want to keep all the tenants separated, and strong authentication can help with that. And of course, if you are operating Lustre in a cloud-based environment, obviously you would need strong authentication as well to guarantee that all your users are separated. So that's a number of good reasons to use strong authentication with Lustre. So we still want, of course, a good performance, but we also need to comply with some security requirements. The first feature that you can use to implement that is a shared secret key. So I really like this feature. It's very nice. Basically, so as the name suggests, it relies on a key that is shared between the Lustre servers and the Lustre clients. And without the shared key, the client cannot mount Lustre. So it's very lightweight. It's a very lightweight mechanism. It allows rapid deployment because it's completely implemented inside Lustre. It does not rely on any external server. And users do not need authentication to authenticate, basically. Only nodes are authenticated with this feature. Also, it's tightly coupled with non-map, which allows a number of very interesting Lustre features. And it's been there for a while, from Lustre 2.9 exactly. Okay, now, I really like shared key, but sometimes you can see it too simple for what you need to implement regarding security. So in this case, you would try to use Kerberos. Kerberos is a well-known authentication mechanism. It relies on a third-party server. And with Kerberos, the main difference with shared key is all nodes need to authenticate. All servers all the clients. Actually, it's not the servers, it's even the targets that need to authenticate to be part of a Lustre file system. And the other main difference is that with Kerberos, end users need to authenticate. Kerberos has been there for a while. It's been initially implemented in Lustre 1.8 or 2.0. It's hard to draw a line. I remember attending LUG in 2010, and there was a presentation from Pittsburgh Supercomputer Center, I guess, presenting their usage of Kerberos with Lustre. And I think it was relying on 1.8 or 2.0. And there was a first revival of Kerberos with Lustre 2.8. I will talk about that a little bit later in the presentation. So imagine that you want to control which nodes can be part of a Lustre file system. Without Kerberos, any client that is on your interconnect network and knows the address of the MGS can just mount Lustre as a client. But even worse, you can add a new target to an already existing file system. And so all the regular users would store their data on this newly and potentially evil target. So Kerberos is a solution for that. So basically, on the right-hand side, you have the Lustre servers. They will first connect to the Kerberos server in order to authenticate and retrieve a service token. Similarly, the clients on the left-hand side will have to connect to the Kerberos server, again, to obtain a service token. And these tokens will be put into the request when clients and servers talk to each other. And the authentication tokens will be checked against the Kerberos server. Imagine that you want to control which users can have access to your files on Lustre. Without Kerberos, well, you only rely on the existing access control mechanisms, such as Unix access rights, ACLs. And with Kerberos, you can you can strengthen security, because the first thing end users need to do is to connect to the Kerberos server in order to authenticate. And only after that, they can try to access files on Lustre. The authentication token will be put into the requests that are sent to the servers. And again, this authentication token is going to be checked against the Kerberos server. So if we look a little bit under the hood, you might know that everything related to Kerberos authentication is implemented in user space. So we have this Kerberos server, which of course runs in user space. The GSS API to communicate with the Kerberos server or to retrieve information about the Kerberos configuration is a user space library. And the thing is, Lustre runs in the kernel. So we have a number of mechanisms to implement Kerberos with Lustre. On the client side, we have this LGSS keyring command, and its responsibility is to connect to the Kerberos server in order to carry out the authentication. So this is the very first step in the Kerberos process to authenticate, and this is done via this command. The authentication token is then exchanged with the Lustre code in the kernel, and then we put the authentication token in the request that is sent to the server. On server side, once again, we need to extract this authentication token, put that, extract that and send that to the user space daemon that is called LSVC GSSD. And so this daemon runs on Lustre servers, and its responsibility is to verify that the provided token is valid. So it's going once again to talk to the Kerberos server and verify that everything is fine regarding authentication. So what to do if you want to configure Lustre for Kerberos. Actually, it's pretty simple to set up Lustre for Kerberos. It's not that complicated. It's just that Lustre imposes to have specific credentials that are named principals in the Kerberos lingo. So as you've seen in the previous presentation, you have dedicated principals for each kind of Lustre service, and also for the Lustre client. And of course, end users, that's the whole point of Kerberos. End users need their own principals. So once this is declared on your Kerberos server, it has to be deployed on the key tabs on the various servers. You must start the LSVC-GSS daemon on all the Lustre server nodes. It's not used on the clients, so it's not necessary, but on the servers it's required. And for Kerberos, we start this daemon with the -K option. So when this is done, the only remaining thing is to actually define a Kerberos flavor. So you can define that globally, or you can refine that per LNet network, or you can even decide to only enforce Kerberos for a given direction. For instance, only between clients and OSTs. Of course, you can secure the communication between the Lustre servers and clients and the MGS. In this case, you have to use a specific mount option. This mount option needs to be used for the client mount and also for the target mounts. So it's -O MGS-sec. And the reason is, when you start a client or target, the very first thing is for the target or the client is to connect to the MGS. So you have to tell the target or client ahead of time which security flavor to use, otherwise it would be rejected by the MGS. As you've noticed, everything heavily relies on the Kerberos server, which is outside of Lustre. Hopefully, Lustre is agnostic regarding the Kerberos implementation. Kerberos is a protocol, and there are many different implementations out there. There are open source implementations like MIT Kerberos or AIMDEL. Not sure about the pronunciation though. And of course there is the Microsoft Active Directory implementation that they are using at NVIDIA. So you can use any Kerberos server, and I would recommend sites that want to implement Kerberos with Lustre might already have a Kerberos server on site that is used for end users authentication, and then you would use the same Kerberos server for Lustre authentication. Now, if you want to play around with Kerberos authentication, try to evaluate and see how it works, you can use, so I put a little project on GitHub, actually it's a fork. It implements a Kerberos server inside a Docker container, so it's very easy to deploy, and it has a script that helps with deployment of the Kerberos principles for Lustre. So it's very targeting, testing, and evaluation purposes. It's definitely not for production use, but at least this is a good starting point if you want to see how it works. Okay, so as I explained earlier, there was a previous revival of the Lustre Kerberos feature in 2.8. Actually, by that time, the Kerberos code was barely compiling, and as soon as you activated it, it was directly crashing. So I worked, at the time, I worked on fixing bugs, but this was done in 2016, and since then we still have the same concerns because this feature was not really used in the field, and of course code that is not widely used contains bugs, and also it's not exposed to more modern environments. So you haven't tested it with new Kerberos server implementations. You haven't tested it with new stuff in the GSS API, for instance. And this is why it needs to be revived once again. So the very first decision we took was to have the Kerberos code regularly tested in Malu. So now Malu is let's say Kerberos aware. It has a KDC. All the nodes in Malu have their own principles. So it's possible to run Kerberos tests. We also fixed the sanity KRB5 test script. So if you use the following test parameter options, you can run sanity KRB5 in Malu. So it means that now at least it's tested in our regular testing environment, and the goal is to have that into a new test session that will be or maybe an already existing, but optional at first, so that it's tested for every new patch being submitted. Of course, there was some cleanup and bug fixing required. I'm not going to, detail every patch in this list. Maybe just the last one about OpenSSLv free support. OpenSSLv free dates back from 2029, and now we can support it. So better late than never, right? One use case we wanted to address with Kerberos is when you mount a client on a Lustre server node. So this is what we call the local client mount. Of course, we do that all the time when we develop Lustre code or when we test. But it's also not unusual to see that in production environments. For instance, for protocol re-export or for data movers. So you have this client running on a Lustre server node. It's called local. And imagine that you activate Kerberos for authentication, but also for integrity and privacy. So it will add a lot of overhead to the communications between this client and the local targets. And it's for nothing, because as we run on the same node, we know that the communication is secure. So what we decided is to disable the security flavor as soon as the client is using the local connection. So on the loopback interface, we do not enforce any security flavor for well, I mean, it's more convenient, it's easier to configure, and it's much more efficient. Okay, so most parts of the rework I'm going to detail now aims at making Lustre more compliant with, let's say, standard Kerberos practices. So this one, I know Aurélien already mentioned, is very commonplace to do UID remapping between the principal used by an end user to authenticate and the UID that is known by the MDS servers. So now we can use what is configured by the security administrator inside the Kerberos configuration file, because it's more natural for security admins to use this configuration file. But we still support the idmap.conf, the old-fashioned way. But at least now we support this more standard way. Credentials cache, once again, Aurélien talked about that. Lustre was very, it was supporting only one cache type and with a hard-coded path. So now we are able to fetch inside the Kerberos configuration file how the security administrators want the cache to be configured, because most of the time people have to comply with security policies that require the use of a given credentials cache type. The principal name is also something that is kind of imposed by Lustre for not necessarily good reasons. So, as we explained before, Lustre requires you to have a principal named Lustre root for your Lustre clients. I wasn't there back for Lustre 1.8 or 2.0. At least I wasn't here for the design decisions that were made regarding that. I guess that it enables you to have a separation between node authentication and Lustre authentication. So having your a Lustre-specific principal makes things completely separated. But imagine that you have a large cluster with a large number of clients. It can be cumbersome to have to declare principals for each of those nodes, especially if this number of clients can change over time. So we now support the host principal as well in Lustre. The main advantage is that it's much less cumbersome for administrators to configure authentication of Lustre clients, and it's also much more efficient in case you need to revoke authorization and authentication for one node. You just revoke one principal and then everything, it's like a kill switch, everything related to authentication of this node, including Lustre authentication, will be deactivated. One thing that Lustre was already kind of compliant with is the use of the Kerberos default realm. So Lustre is already capable of fetching this information from the Kerberos configuration file. So you would say this is fine, but the thing is, as you've seen from the previous presentation, you can have the case where your node is part of multiple Kerberos realms. And in this case, and as an administrator, you have to specify, you have to tell Lustre which Kerberos realm to use. So now the LGSS keyring command takes a new -r option to let you specify the Kerberos realm to use, and similarly, LSVCGSSD has a -r option for the same purpose. Okay, last item on my list, last but not least, is the support for large Kerberos tokens. So, to give you an idea, I told you that we are running Kerberos tests on Melu. In this cluster, the usual size for Kerberos tokens is less than 1 kilobyte. But there are use cases, Aurélien mentioned, this is, in their case, related to free IPA. There are authorization extensions that can be activated, which would enlarge the size of the Kerberos tickets. Also, we've noticed that when your user is part of many supplementary groups, then all those supplementary groups are added to the ticket, and then it makes it bigger and bigger and bigger. And we can end up to tickets up to 64 kilobytes. So we have to support that. It's not, initially when I saw reports about that, I was thinking there is a problem with the Kerberos server, but no, this is completely legitimate and we have to support that. We have to overcome a number of hurdles. There is one limit on the Lustre client side, and it's quite easy to work around. We have a buffer allocated to contain the Kerberos token, and it was simply too small. So we increased the size of this buffer, and the problem on the client side was solved. But then we hit another issue, but on server side this time. And actually, you have to understand that the initial implementation of Kerberos in Lustre was based on what was done for NFS, and it heavily relies on the Sun RPC cache mechanism. This is a mechanism provided by the kernel, and it's a mechanism that handles both cache for the tickets and also the communication between kernel and user space via an upcall and then downcall mechanism. And there is a limitation in the Sun RPC cache, which limits the amount of data that you can exchange with between kernel and user space, and this limit is page size. Unfortunately, most of the time do not run servers on ARM platforms. So basically, most of the time we are limited to 4K. So we thought about the best way to address this limitation. We looked at the current implementation of SonarPC cache in the kernel. Even in most recent kernels, there is still this limitation. It hasn't been addressed. And the main reason, in my understanding at least, is that NFS is not using SonarPC cache anymore for Kerberos authentication. So there was no more need for an update on this. We looked at how NFS currently implements Kerberos authentication, and it's way too specific. And our Lustre code needs to handle Kerberos authentication, but also shared secret key, the other feature that also relies on the GSS API. So we decided to go for a Lustre-specific solution based on an already existing mechanism. Aurélien already mentioned that. This is the upcall cache mechanism. So again, it's a mechanism to handle caching and communication with kernel space as well. It's already used in Lustre for supplementary groups. We had to tweak it a little bit to make it more generic, actually. And the very nice thing in this rework is that we do not touch the actual GSS context negotiation mechanism. This is this code, which is very Kerberos specific, is not modified. We are only changing the way we cache tokens and the way we exchange information with user space. So this is still in progress, but it's progressing well, and it should be landed hopefully soon. So to conclude, we can say that we have in 2.16 a new Kerberos revival. Code is much nicer this time. At least I like to think so. And I hope you understand that this code is actually used in production sites, like at NVIDIA. And so it's really used in the field, and hopefully it means that we will not need any new revival, and this feature will be, as many other Lustre features, something that is used and reliable on the long term. And that's all for the presentation. Thank you. Any questions?
Hey, would you touch base a little bit about how does this work with NFS export Lustre?
I'm not a specialist for that kind of.
We use the same infrastructure with Kerberos, or we have to create a new?
No, my point was, if you use, so usually when you do NFS re-export, you use a Lustre client for NFS re-export, you would locate this client on a Lustre server. And in this case, it's not necessary to enforce Kerberos authentication for this node, because it's going to add overhead, which is completely useless regarding what it brings in terms of security. So my point was, if you use such nodes, there will be no authentication locally on the node.
I would like to add to that point that actually this is working for not only for client-to-server communication, but also server-to-server communication. So if you enable Kerberos for, by example, OST to MDT traffic, and on the same servers you have MDT and OST, this feature will be used. So in that case, you won't. It will be communicating through loopback, and so you won't have Kerberos. So it's not limited to client running on servers. It's also useful for servers-to-server communication if you enable Kerberos for that.
So you say in the configuration you can decide between which kind of servers or clients we want to activate Kerberos. Do you have like any example in real life, why you don't want to have it enabled for everything? Why you would limit it to between, for example, like the example was client to OST?
I guess it's about how paranoid you are. I mean, no, more seriously, it really depends on how your compute cluster is organized compared to your Lustre servers. If they are in the same, really in the same infrastructure, you would tend to think that you would need if you need authentication between clients and servers, then you would also need authentication between servers. On the opposite, if your servers are really in a separate part of the cluster over which you have much more control, then in this case, it's not worth adding this extra overhead of authentication, because this is already a trusted environment. So it really depends. As I mentioned at the beginning of the presentation, for instance, if you operate in a very traditional HPC center, or as opposed to a multi-tenancy with clients coming back and forth, the security requirements can be completely different.
One comment on that is actually you should think also more SS key, so shared key and WAN. This is the kind of deployment where this is used. Like there was some deployments where the file system was distributed in a WAN environment, and in that case you wanted to have GSS communication being encrypted. To enable GSS for servers to servers communication because they were not on the same site or things like that. And this deployment, it was using shared key, by example, not Kerberos.
Okay. No questions? There is one in the front, Quentin. Thanks.
Sorry, I feel a bit cheeky asking this, but there's no chance of backporting this to an LTS, is there?
Maybe 2.16 will be the next LTS, as Peter said. So. The code, the Kerberos code has not evolved a lot from previous versions, so I don't think it would be hard to do. But taking this decision is another.
With regard to that, obviously this is being used in multiple production sites, but it still is early in the stages of that happening. So yeah, we could, potentially it could be, I suppose, but then it's a trade-off between the sort of vast majority who are not going to use that feature, and if there's some risk about all the code change going in. So it is always, a balancing act when you sort of make that kind of decision. Yeah.
Okay, thanks everyone. Thanks, Sébastien.
Thank you.